Hello and welcome. My name is Daniel Del Foro. Welcome to my tutorial. I will show you a little bit how to control lasers with TouchDesigner. More specifically, this tutorial is part one of a total of 3 tutorials, and it's built around using a Fanon accurate laser from Laser Animation Zollinger, using the new laser chop from TouchDesigner, and controlling everything with the AVB protocol. So basically, let's look at the setup. I've got a Windows 10 PC, a laptop. I'm using a USB to AVB device from Laser Animation Zollinger, which is connected to my PC over a USB 3 cable, and I'm using the Fanon Accurate from Laser Animation Zollinger. And installed on my computer is TouchDesigner, the LA toolbox, and drivers from RME, the DigiFace AVB driver, and the ASIO for all driver. So in the next steps, let's look at the installations. So first of all, you install the LA toolbox. The links and files are in the description of the video. So yeah, let's just go through it quickly. Let's install LA toolbox. The LA toolbox is also from the Laser Animation Zollinger. It's kind of the interface to our laser, and it kind of creates the first tools that you need to talk with the laser. So we will look at it more in depth quickly. The next step is installing the RME drivers. Also links in the descriptions. It basically enables us to communicate with the interface in between my laptop and the laser. I'm not sure because I don't have a Mac, but I think you can, with a Mac, you can even jump the interface because you can output AVB directly. You don't need a USB to AVB interface, but I'm not really sure. So I can only show you this way. So basically, when you have the RME driver installed, our USB to AVB device will pop up as a network. So it becomes a network card. And now if we open the LA toolbox, we see our laser popping up as a device in our device list. And just to make sure, let's change the IP address of our laser so that it kind of lives in the same subnet. As soon as we made that, we have full access to our device. So let's choose our laser and connect. Let's hit details, and then we can look at our laser settings. Here we go. A more detailed description on the LA toolbox you can find on the LAS website, but let's just go through the aspects that are important for our settings. So you can see here the different sources that you can select, and most of the time we use ILDA, but in this case we switch to AVB, audio video bridging. And what we have to make sure is that we use the same sample rates on both the laser and our AVB, USB to AVB interface, which is in our case 96,000 Hertz. And so we can connect to the laser on 96,000 Hertz. So now we are up and running basically. We are choosing the test pattern, and there we go. We have the circle. So let's check this next input source. It's called DGC, which means Digital Geometric Correction. And what you can do with it is you can kind of normalize your projection area to desired surface, which is in my case this white small canvas. So basically I can set this canvas to be my new normalized projection area from -1 to 1 in both X and Y area. So this is basically an out-of-the-box mapping tool that you have in LA Toolbox, which you don't have to do anything in your application, in your software. That's all in the LA Toolbox. It has some very nice UI for it with some fine adjustments that you can do. So yeah, I've got my new projection area on my canvas here in very few clicks. So as soon as we have this DGC mapping, we can now see that if I go back and show the test circle, I'm bang on the middle. So let's have a look at TouchDesigner now. So this patch that you see is on my Git profile. You can use this repo. The link is in the description of the video. You can use anything that you want that is in this patch. Yeah, let's have a look. Let's output our first shape, which is a red circle, and this setup is really the bare minimum of what you need in TouchDesign. It's very fast to get shapes to an output. So I'm just using a points up to add color to a circle and ending with a null, and you already have the laser chop here, which is there to output the necessary values. You see the 96 kilohertz that we had in our LA toolbox. You do have a lot of parameters in the laser chop, which I will talk to more in depth in my second part of this tutorial in the other video. But yeah, so basically the laser chop is the new chop that we use in TouchDesigner to produce those values for the laser. It was the scan chop before, which was kind of made for oscilloscopes, but with the help of Laser Animation Solinger, who contributed a lot for this chop, we are now blessed with this new laser chop. So the laser chop produces these X and Y values and RGB, and let's look at how we actually send them to the device. So here's my null. You see X, Y, RGB. I have this camera component here which I use for the preview. I guess you just will check more of this out when you use the patch. Yeah, you see I made like a small 3D preview on the top right, which you can see here in the space component. I also made this output container. This is actually producing or displaying what the laser is really outputting. It tries to kind of show you the 2D image. And after the laser chop, the other important node is the node that we will use for outputting our data, which is a audio device out chop. It sounds a bit peculiar, but it's basically we are treating our laser as if it was a audio device. AVB, as I mentioned, means audio video bridging, and so basically we are sending audio signal X, Y, RGB values to our laser, and there we go, our red circle normalized onto our beautiful canvas. Make sure you're using the ASIO drivers that we installed on our computer before, and then it's really up and running. So very fast setup, one SOP, a laser chop, and an audio device out chop. These are the key nodes that you use. I'm just showing you how to very quickly change coloring, but this is just a very basic example. Yeah, so thank you very much for listening. I hope I could help you in getting started with this kind of setup and using TouchDesigner and a laser animation soldering a laser with the new laser chop and the AVB protocol. Thank you.